In finding the domain and range of a certain linear function, there are two conditions that we should follow. First, y is equal to k, and its domain is equal to x such that x is an element of real numbers, while its range is equal to y such that y is equal to k. Example, find the domain and range of a given linear function y is equal to 5. Go back to the first condition so that we will get the domain and range of y is equal to 5. So the domain of y is equal to 5 is x such that x is an element of real numbers, while its range is y such that y is equal to 5, wherein the k is equal to 5. The second condition is y is equal to mx plus b, wherein m is not equal to 0. The domain of the second condition is x such that x is an element of real number, and its range is also y such that y is the element of real number. Example, find the domain and range of a given linear function. Y is equal to 2x plus 2. So we will follow the domain and range in a second condition, and we will apply it on a given linear function, which is y is equal to 2x plus 2. The domain of y is equal to 2x plus 2 is x such that x is an element of real numbers, and its range is equal to y such that y is an element of real numbers. So the next is finding the domain and range of quadratic equation. But first, we all know that the standard equation of a certain quadratic equation is y is equal to ax squared plus bx plus c. In finding the domain and range of quadratic function, there are two conditions that we should follow to get the right domain and range of a certain quadratic equation. The first condition in finding the domain and range of a certain quadratic function is if the given a is positive, the domain of quadratic equation is x such that x is an element of real numbers, while its range is y is greater than or equal to 4ac minus b squared over 4a. So first, we will identify the a, b, and c of a certain quadratic equation, and we will proceed to the range, which is y is greater than or equal to 4ac minus b squared over 4a. The value of a, b, and c will be substituted in the given equation. Example, find the domain and range of a given quadratic equation, which is y is equal to x squared plus 2x plus 2. So we will apply the first condition in quadratic function. So the domain of y is equal to x squared plus 2x plus 2 is x such that x is an element of real numbers. In finding range, identify first the a, b, and c, and we will substitute it in equation 4ac minus b squared over 4a to get the range. The a is equal to 1, the b is equal to 2, and the c is equal to 2. And now, substitute it in a given equation 4ac minus b squared over 4a to get the range. So the range is equal to y is greater than or equal to 4 times 1 times 2 minus 2 squared over 4 times 1. Y is greater than or equal to 8 minus 4 over 4. Y is greater than or equal to 4 over 4. And the final range is equal to y is greater than or equal to 1. In second condition, getting the domain and range of certain quadratic function is if the given a is negative, we will use the domain x such that x is an element of real numbers and its range is y less than or equal to 4ac minus b squared over 4a. Just like the first condition, we will get the a, b, and c to proceed in a final range. But in the second condition, we will use y is less than or equal to. Example, find domain in range of negative x squared plus 3x plus 1. So first, we'll find the a, b, and c. The a is equal to negative 1, the b is equal to 3, and the c is equal to 1. And now, we all know the a, b, and c of the quadratic function, which is a is equal to negative 1, b is equal to 3, and c is equal to 1. The domain of given equation is x such that x is an element of real numbers while its range is y less than or equal to 4 times negative 1 times 1 minus 3 squared over 4 times negative 1. So y less than or equal to negative 4 minus 9 over negative 4. So we'll proceed again. Y is less than or equal to negative 13 over negative 4. And the final range is y is less than or equal to 13 over 4.